Okay, hello guys. So this is section 18.3. Section 18.3 is about multiplication property of radicals. So we're going to start with definition. So let A and B represent real numbers. Such that radical of index n of A and radical of index n of B are both real. So technically, we're not dealing with imaginary numbers. Then radical of index n of product A times B is the same as radical of index n of A times radical of the same index of B. Okay, so this is multiplication property. And what we're going to do next? Next, we're going to simplify. Before I will jump to the examples, I will give you 3 rules how to simplify form of a radical. So let's just write this down for you guys. Simplifying radicals. Okay. So couple rules. Number 1, to simplify radicals, the radicand has no factor raise it to a power greater than or equal to the index. Number 2, the radicand does not contain a fraction, and 3, there are no radicals in the denominator of a fraction. So what I gave you guys, I gave you the 3 cases when radicals cannot be simplified. So they are already in simplest form. So I should write this down. Let me just fix it. Here. Then I will put that for you this way. The expression is in simplified form if all the conditions, if all three conditions are met. So let's leave it that way. Okay. So if you have a cases like the three which I gave you, you don't need to worry about simplifying radicals. Okay, so that means case number one, the radicand has no factor raised to a power greater than or equal to the index. The radicand does not contain fractions, and there are no radicals in the denominator. And let's just work on the example so we can see how to simplify the radicals. So this is example one. What we need to do, we need to simplify the expression. Okay, and we have a, we have square root of a to the power of 11. Okay, so how are we going to simplify that expression? So what we want to know, what we know that the index of this radical is 2. So what we can do with rewriting square root of 11, we can rewrite that as a raised to the power of 10 times a raised to the power of 1. Because we already know the product property, like you guys see, a to the power of 10 times a to the power of 1, we can rewrite it as a to the power of 11. So why we do that? Because I want to use, at this moment, the multiplication property of radical. So I want to rewrite this as square root of a to the power of 10 times square root of a. Okay, and square root a to the power of 10. That will give you a to fifth power times square root of a. We cannot simplify. So the final solution will be a to the power of 5 square root of a. Okay, and also just to show you that square root of a to the power of 10. Okay, what we can do, why this is a to the 10 power, because again, maybe that will help you. You can rewrite that as a to the power of 10 over 2. Again, what I'm doing, I'm using the section 18.2, so I'm changing the radical into exponential expression, and that will give you a to the fifth power. Okay, so this one I just show work, how I end up with a to the fifth power. Okay, so we can practice more of simplifying radicals. Maybe we can simplify a little more advanced problems. I'm trying to find something better for you guys. Okay, let's do B. More examples. Okay. Okay, so we continue. So next one, which we're going to do, it's going to be radical of index 4 of v bring to the power of 25. So what we want to do, we want to rewrite that as a radical of 4 of v to the power of 24 times v to the power of 1. So when you add the powers, you end up with v to the power of 25. Now, how I know to pick 25? Because here, when I'm changing the expression, the radical, so I always pick the number which can be divided by 4, which is the index of the radical. Okay, and then the other one is usually v to the power of 1 of something what is left after using the product property of exponents. So now what we're going to do, we're going to rewrite that as radical of index 4 of v to the power of 24 times radical of index 4 of v. And here from radical of index 4 of v to the power of 24, that will be v to the power of 6. So the shortcut is how quickly I know that this is v to the power of 6. So technically what I'm doing, that's a shortcut, that I'm taking that 24 right here and divide by 4. So 24 divided by 4 will give you 6. But to show it correctly, again, radical of 4, index 4 of v to the power of 24 is the same as v to the power of 24 over 4. And this is just v to the power of 6. But you don't really need to show that work. Again, just use the shortcut 24 divided by 4, and that will give you 6. Times radical of index 4 of v. This expression cannot be simplified, so this is our final answer. And why this one cannot be simplified? Because we those three rules, that's the expression which we cannot simplify. The radical has no factor raised to the power greater than or equal to the index. So the index of this radical is 4. So like you see, the v, it's being raised to the power of 1. So we only can simplify the radical if the power next to v will be 4 or more than 4, so greater than equal to the index of the radical. Okay, so just remember that. So this is the simplified form. And let's do C. So we have the cube root of p to the power of 17 times q to the power of 10. So I'm going to rewrite that as cube root of p to the power of 17 times cube root of q to the power of 10 equal. So first, I'm going to simplify the cube root of p to the power of 17. So this one definitely we can simplify because you see the power inside of the radical is greater than index, which is 3. So how you want to rewrite that? You want to rewrite that p to the power of 17 as, let's see, division. Let's do as p to the power of 15. Why I pick 15? Because I know that 15 can be divided by 3 times p, and again we want to get 17, so we have power 15, so we're missing 2, so that will be p to the second power. So now this is the same as cube root of p to the power of 15 times cube root of p to a second power, and cube root of p to the power of 15, so use that shortcut, that will be p, and 15 divided by 3 will give you 5. And this one, cube root of p to a second power, we cannot simplify that because the exponent inside of the radical, it's less the index of the radical. So we're just going to copy that as cube root times cube root of p squared. Okay, so I will save that. So this is cube root of p to the power of 17. So the answer is p to the power of 5 times cube root p squared. Next, what I'm going to do, I'm going to simplify this part. Cube root of q to the power of 10. So we can simplify that radical. So let's just break it down. Q to the power of 10 as q to the power of 9 times q to the first power. Again, why I pick 9? Because 9 divided by 3, it's 3. I can simplify that. And we need power 10, so I'm missing 1. And now let's rewrite that as a cube root of q to the power of 9 times cube root of q to the power of 1. So cube root of index 3, cube root of q to the power of 9 will be q to the power of 3. Again, what I did 9 divided by 3. And I end up with 3. Now, cube root of q cannot be simplified because the power inside the radical, it's less than index of radical. So we cannot simplify. So just copy this down, times cube root of q. Okay, and this is this part, cube root of q to the power of 10. So let's just combine them together. So that will be times q3 cube root of q. And now we're going to simplify them. So we have, let's move everything what doesn't have radical in front. So we have p to the 5th, q to the 3rd, and then we have radical of index 3, p squared, times radical of index 3 of q. So to simplify that here, so this is p to the 5th, q to the 3rd. Since they both radicals has index 3, you can rewrite that as one radical. So cube root of, and just put pq and q together under radical. p squared times q. Okay, so this is final solution. And of course, it's a product between all of them. When you guys using my MATLAB, Alex, just don't put any space, okay, between between the expression. Okay, so that was the answer. And I want to do one more example of simplifying, now using the real numbers. So D, we have to simplify square root of 56. So what we're going to do with 56, again, we can not say it what is square root of 56 because there's no number which we can square it and end up with 56. So you want to break this down into, so let's think what's going to work. 4 times 14. Okay, so let's rewrite that as square root of 4 times 14. Yeah. Okay, yes, just double check. Okay, so now why we pick the first number 4? Because we know what is square root of 4 times square root of 14. We cannot simplify that. So square root of 4, it's 2. Square root of 14 we cannot simplify, so that will be our simplest form. Okay, let's do E. Let's simplify square root of 24. So let's break down this 24 into 4 times 6. And this is the same, use product property as a square root of 4 times square root of 6. So square root of 4 is 2. Square root of 6, we cannot evaluate that. I mean, this is irrational number. So we just copy 2 square roots of 6. Just don't make a mistake. This is not the same as 2 radical of index 2 of 6. No, this is not the same. This is 2 times square root of 6. That's the meaning. Okay. Okay, so the next one are also more. I'm checking the examples, have a book in front of me to making sure that I cover everything what you guys need. Okay, we're still going to work on using multiplication property to simplify radicals. So let me give you more examples, a little more advanced. So let's simplify 5 times square root of 18. So this is 5 times square root of 18. So how are we going to simplify? 5, it's 5, so we copy 5 times. Square root of 18 you want to simplify. So we can break down 18 into 9 times 2. So we have 5 times, and here we're using the product property. So that will be square root of 9 times square root of 2. And that will give us 5 times square root of 9, it's 3. Square root of 2, it's irrational, so we just copy square root of 2. And now you will just multiply numbers together. So 5 times 3, that will give you 15 square root of 2. Okay. Maybe one more. G, 6 square root of 50. We have to simplify. So copy the 6, rewrite 50 as 25 times 2. And why I picked 25? Because we know what a square root of 25. So that will be the same as 6 times square root of 25 times square root of 2. And this is 6 times square root of 25. It's 5. Square root of 2 we can't simplify. And that will give you now, we multiply numbers in front of the radical. So this is 30 square root of 2. Okay, so that's the answer. Okay, and what else? Let's see, more advanced problem. So H. So we have radical of index 4, and we have huge expression 32, A10 to the power of 10, B to the power of 19. So we need to simplify that. Okay, so what we're going to do, I just recommended to break this down as a radical of index 4 of 32 times radical of index 4 of A to the power of 10 times radical of index 4 of B to the power of 19. Okay, and I will simplify one by one. So I'm going to start working with this one first. 4 square root, I'm sorry, not 4, radical of index 4 of 32. Let's break this down. Let's find the number which can be divided by 4. So 32 is the same. 8 times 4, 16 times 2. No, 16, 16 times 2. So now we have okay. So now we have 4 radical of index 4 of 16 times radical of index 4 of 2 Okay, so here, what is the radical of index 4 of 16? So you guys may thinking, you may think that way, that 16 is the same as 2 to the power of 4. And think of, so that will give you 2. 4 divided by 4 is 1, which is 2. So radical of index 4 of 16, it's 2. Because if you want to rewrite that using exponents, so this is 4 divided by 4, 2 to the power of 1, which is 2. So from here we're getting 2. And radical of index 4 of 2, we cannot simplify because the power of 2, it's 1. And like you see, to simplify the radical, this power should be 4 or greater than 4. So I simplify the first expression right here. So I'll just put that. So that's equal to radical of index 4 of 2. Now let me work with this one. Radical of index 4 of a to the power of 10. So we want to rewrite that as a to the power of 8 times a to a second power. And why I pick 8? Because 8 can be divided by 4. So that is the same as radical of index 4 of a to the 8th power times radical of index 4 of a squared. That will give us a, and again, 8 divided by 4. So shortcut, let's use the shortcut. 8 divided by 4, it's 2. And here, radical of index 4 a squared can't be simplified because like you guys see it, 2, it's less than 4. So to be able to simplify radical, the power inside of the radical should be greater or equal to 4. So I just copy that as times radical of index 4 of a squared. Okay, so that's that second expression right here. So let me just copy this down. So times a squared radical of index 4 of a squared. And the last one which we need to simplify is this one. Radical of index 4 of b to the power of 19. So let's break this down as b to the power of 16 times b to the power of 3. And I pick 16 because 16 divided by 4 will give me 4. And to get 19, which is original power, I'm missing 3 left. So rewrite that as a radical of index 4 of b to the power of 16 times radical of index 4 of b to the 3rd power. So that will give us b to the power of 4. Again, this part, this is just b to the power of 16 divided by 4, which is b to the power of 4. Okay, right here. And the second expression we can simplify, so just copy times radical of index 4 of b cubed. Okay, so that's that last one here. So let's just copy this down to our solution. Times b to the power of 4 and radical of index 4 b to the 3rd power. And now we're going to put everything together. So first what we're going to do, we're going to multiply the numbers which we have in front of the radicals. So that will give us 2a squared b to the power of 4. And since all the radicals has power of 4, so we're going to just copy one radical of index 4 and put all the expression a squared 2 and b to the third power under radical. So that will be 2a squared b cubed. And that can't be simplified. So this is our final solution. Don't forget it's a multiplication between all of them. So definitely a long problem. I have 3 more examples for you guys, showing you how to simplify the radicals. Okay, so the next examples we're going to simplifying radicals. I will call that example 2. Simplifying radicals by using the order of operations. Okay, so let's do a couple examples. A, we have square root of v to the power of 21, this one, over v to the 5th power. So first what I'm going to do, I'm going to simplify this expression under radical. So since those exponents has the same base, so I will just put that as a v, and we have division, so we're subtracting exponents. So this is 21 minus 5. And that will give you square root of v. We have, let's put that v better. We have 21 minus 5, which will be 16, v to the power of 16. And now don't forget that index or square root is 2, so this is the same as v to the power of 16 over 2, which is v to the power of 8. So that's the final answer. Now let's do more. Okay, next one, b. We have radical of index 5 of 64 divided by 2. Okay, so let's simplify. So this is radical of index 5. So 64 divided by 2, this is 32. Aye. Radical of index 5. 64 divided by 2, this is 32. Okay, and we want to simplify. So if you guys want it, maybe that will help you. But we can rewrite that 32 as 2 to the power of what? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So 2 to the power of 5. So 32 is the same as 2 to the power of 5. And now to simplify that, so change that to exponential. So this is 2 to the power of 5 divided by 5. So again, this one divided by this one. So this is what we learned from previous section. So this is the same as 2 to the power of 1, which is just 2. Okay, so that's the answer. And what else? Maybe one more with fraction, cube root of 3 over 81. So this is the same as cube root. Let's simplify that fraction first, 3 and over 81. Both numerator and denominator you can divide by 3. So let's reduce that fraction. So 3 divided by 3 it's 1. 81 divided by 3 it's 27. And now you use what we can do. We reduce to the lowest form of the fraction, and now we can simplify. You can rewrite that as a cube root of 1 divided by cube root of 27. Okay, and cube root of 1 is 1. Now cube root of 27 will be 3, because again 27 is the same as 3 to the third power. So I have 1, and then cube root of 3 to the third power. We can rewrite it as 3 changed to exponential, 3 divided by 3. So this is 3 to the power of 1, which is just 3. So we have 1/3 as a final solution. And the last one, D, we have 2 times square root of 300 divided by 30. So first of all, I'm just going to rewrite that as a 2 over 30 times square root of 300. So 2 over 30, let's reduce that fraction. So this is 1 over 15. Okay, and then we have square root of 300. So we can rewrite that 300 as 100 times 3. So let me on a side just simplify that square root of 300. Square root of 300 is the same as square root of 100 times 3. So this is the same as square root of 100 times square root of 3. Square root of 100 it's 10. Square root of 3 we cannot simplify. So this expression is equivalent to 10 radicals of 3. So we have 1 over 15 times 10 radicals of 3. So let's simplify. So this is the number multiplied by fraction. We multiply numerator only. So we have 1 times 10 radicals of 3 divided by 15. So 10 and 15, we can reduce them by 5. So we're getting 1 times 10 divided by 5, it's 2 radicals of 3. And 15 divided by 5, it's 3. And now we just multiply the numbers. So 1 times 2, it's 2. So we have 2 radicals of 3 over 3. That's the final solution. One more like that, just for those who need additional examples. Almost the same. 7 square root of 50 divided by 10. So what I'm going to do, I'm going to simplify the square root of 50, rewrite that as a square root of 25 times 2. So we're using product property. This is the same as square root of 25 times square root of 2. Square root of 25, it's 5. Radical of 2, we can simplify. So let's go back to this problem. So we have 7. Square root of 50 is times, because it's a multiplication between all of them. Square root of 50, it's 5 square root of 2 divided by 10. So 5 and 10 you can cancel. 5 divided by 5 it's 1. 10 divided by 5 it's 2. So we're getting 7 radicals of 2 over 2. And that's the final solution. So that's it from section 18.3, simplifying radicals expressions. Hopefully the lecture and all the problems which I went over will help you to study this section. Okay, tomorrow I will post the remaining 2 sections of the semester. Thank you for watching.